Hello everyone. Today we're working on Module 2, Lesson 6, and we'll be connecting area models and the distributive property to partial products of the standard algorithm, just like we did last week. The difference is this week we'll be working with larger numbers, and sometimes we'll have to regroup or rename the numbers. Let's start with 64 times 73. Now this is a 2-digit by 2-digit number, and even though both factors have 2 digits, there are no zeros involved, so it's going to be slightly different than it was last week. So instead of just multiplying by 73, we're actually going to break that apart and to its expanded form and have 70 and 3 on our area model. So we're going to start off by taking 4 times 3, which is 12 ones, and 4 times 7 is 28, but 70 is 7 tens, so that means we have 28 tens, and 28 tens is 280. Now we're going to move down to the lower boxes in our area model. And 60 times 3 is, if I'm going to first just think of the basic facts, 6 times 3, which is 18, but this is actually 6 tens times 3, so that's going to be 180. And then 6 times 7 is my basic fact for that last box, but of course it's 6 tens times 7 tens. So 6 times 7 is 42, and since I also have a 10 times a 10, that's going to be 42 hundredths. And now what I'm going to do is add a cross. So I have 280 plus 12, which will be 292, and I've got 4,200 plus 180, which is going to equal 4,380. And after we get our partial products, 292 is one partial product, 4,380 is the other partial product. We're going to add those two partial products together. And we'll start in the ones place. 2 plus 0 is 2. 9 plus 8 is 17. And we have to carry a 1 here. That's 17 tens. So that means we have 100 and 7 tens. And this 1 plus 2 is 3. And then the 3 in the hundreds place will be 6 hundreds total. And then we just have that 1 4 in the thousands place. So our answer will be 4,672. So let's take a look at using the standard algorithm for this. We want to make sure that we use the same number on the top of our standard algorithm as we did on the top of our area model. Otherwise, our partial products will be different. And we're going to multiply 73 times 64. And when I take 4 times 3, I get 12. And I'm actually going to write a little tiny 1 up here to help me remember that that is a 12, not just a 2. And 4 times 7 is 28. But this is 4 times 7 tens, so it's 28 tens. And I've already got a little 1 up there for 110 that I regrouped from doing 4 times 3. So when I write my number down, I'm going to add in that 110 to my 28 tens, and I get 29 tens. And then I'm going to cross off that little 1 to show that I've added it in to my partial product. And then I'm going to check and see, yes, that is the same partial product I got last time. Now for, I'm going to move down to the 60 minus 73 part. And since this is a 60, I know I'm going to multiply my answer by 10. And I'm going to go ahead and put a 0 in the ones place, because whatever I'm come up with is going to have a 0 in the ones place. Now 6 times 3 is 18. And that's 18 tens. So I have 10 tens plus 8 tens is 18 tens. And those 10 tens are going to move over here because they make 100. So I'm going to put a little 1 in the hundreds place and my 8 in the tens place. And then I have 6 times 7. And 6 times 7 is 42. But I want to add, that's 42 hundreds, but I have this 100 here that I regrouped from my last operation. So instead of 42, I now have 43 hundredths, which is the same as 4,300. I'm going to cross off that one that I regrouped to show that I've used it up. And now I'm going to add, first I'm going to check and make sure I got the same partial product, and yes I did. Now I'm going to add my two partial products together. 2 plus 0 is 2, 9 plus 8 is 17, and I have to regroup again. So I'm going to carry that 1 over. That's 17 tens. So I have 107 tens, and I have to put that 1 up here in the hundreds place. And 1 plus 2 plus 3 is 6, and I'm going to show that I've used that one by crossing it off. And then I have only the 4 in the thousands place, and I know there's an invisible 0 in the thousands place for my first partial product. So in my end result, I will have a 4 in the thousands place, and my answer is 4,672. And I can see it matches in my standard algorithm and using the area model. So I'm confident of my answer. Okay, now it's your turn. You're going to multiply 35 times 23. I would like you to do it one time with the area model and then use the standard algorithm. If you prefer the standard algorithm, I still want you to do the area model to check yourself. And if you prefer using the area model, I want you to do the standard algorithm and use the area model to help you understand how the standard algorithm works, because of course our ultimate goal is to move on to using the standard algorithm. So find the answer, doing it both ways. If your answers don't match up, go back and check your partial products and figure out where you made your mistake, fix it, and make sure you're 100% confident of your answer before you write it on the Edpuzzle quiz. Now we're multiplying a 3-digit number times a 2-digit number. And when we're using the standard algorithm, we like to put the numbers with more digits on the top, because that means that when it comes to the adding part, we'll have fewer partial products and we're less likely to make a mistake with the adding part. So I'm going to put 814 on the top since it has 3 digits, and I'm going to multiply that times 39. And I figured out how to arrange my standard algorithm first because I want it to reflect how I arrange my area model. So now I know that I want 800, I'm going to write it in expanded form, plus 10 plus 4 up on the top. And then on the side, I'm going to have 30 plus 9. But of course, I'm going to write the ones on the top and the tens on the bottom. Now I'm going to start, I always want to start over in this upper right-hand corner. And 9 times 4 will be 36 ones. 9 times 10 will be 90, or 9 tens, and 9 times 800 will be 72 hundredths, or 7,200. Now I'm going to move down below, and I'm multiplying 30 tens times 4, which will be 12 tens, also known as 120, and 30 tens times 10 tens. 3 times 1 is 3, and a 10 times a 10 is 100, so I'll have 300 in this box. And then in my last box, I have 3 tens times 8 hundredths, and that's going to be 24, and 10 times 100 is 1,000, so 24,000. My next step is to add across 7,200 plus 90 plus 36, and I know I have a 6 in the ones place. I'm going to add that 3 to the 9 and to a 0 in this number. 3 plus 9 is 12 tens, and that means I'm going to have one more 100 because 10 tens is 100. 2 plus 1 is 3 in the hundreds place, and then I'll have that 7 in the thousands place. Now I'm going to move down below and add 24,000 plus 300 plus 120. And I'm going to have, I don't have any digits except for zeros in the ones place, so there will be a 0 there. And then I have a 2 plus a 0 plus a 0, so there will be a 2 in the tens place, and a 1 plus a 3 plus a 0, so now I've got a 4 in the hundreds place. And then the thousands place and the tens thousands place, I just have that, the 2 and the 4. So I'll put those down. Okay, and now I have to add from top to bottom. 6 plus 0. Sorry, don't know what happened there. 6 plus 0 is 6. 2 plus 2 is 4. 3 plus 4 is 7. 7 plus 4 is 11. And that's 11,000, so I have a 1 in the 10,000s place. So I have 31,746 as my final answer. Now I'm going to do the same thing with using the standard algorithm. 9 times 4 ones is 36 ones. So I'll put a 6 in the ones place, and that 30 is actually 3 tens. So I'll put a tiny 3 in the tens place. 9 times 110 is 9 tens, plus that tiny 3 is going to make it 12 tens. That means that I'll have 102 tens. And then 9 times 8, of course, is 72. And that's plus this 100 that I already have. 72 hundredths plus 100 is 73 hundredths. Now I'm going to check and see if my partial products are the same, and they are, so I'm feeling good about continuing on. Now I'm going to be looking at this 3 in the tens place, and I know since I'm multiplying every digit in that top number by 3 tens that I will have a 0 in the ones place. And 3 tens times 4 equals 120 tens. Sorry, equals 12 tens. That means I have a 2 in the tens place, and that 10 tens will become 100. And then I move on to the 3 times 3 tens times 110, which is going to give me 3 hundredths, and I've got this 100 that I carried over for my last operation, so I have a total of 4 hundredths now. And then last but not least, I'll multiply 3 tens times 8 hundredths, which is going to give me 24, and tens times hundreds is thousands, so it should be 24,000. And again, I'm going to check and see that it matches up with my partial product for my area model, and it does. So I know I'm ready to add everything up. 6 plus 0 is 6. 2 plus 2 is 2. 3 plus 4 is 7. 7 plus 4 is 11, and that's 11,000, so that means I'll have 1,000, and then I'll carry or regroup those 10,000s over to one 10,000. One 10,000 plus 2 is 30,000. So my final answer, 31,726, and it matches up with the answer I got in my area model. Now it's your turn again. You're going to multiply a 3-digit number times a 2-digit number. I'd like you to do both the area model and the standard algorithm, and you need to pay careful attention to your non-preferred method and compare it carefully to your preferred method, because you're most likely to get a correct answer on your preferred method. Make sure you know how to do it both ways, because tomorrow in class, when you're working on the problem set, you and your partner will be taking turns doing the standard algorithm and the area model for each problem, and then checking your work against each other. So good luck, and I'll see you in class tomorrow.